Alrighty. Whoops. True. I get trues. I get any trues in chat? Okay. So you guys know area today. So today's about volume and surface area. You guys already know area. You guys know volume. You guys know surface area. But just quick review. So here are the equations. So for a square, recall that area equals the side squared. So your square right here, S and S. And remember, a square, all four sides are the same. That's what makes it a square. If that's not the case, then it's not a square. It's a rectangle then. What's true? Oh, someone, don't worry about it. Don't worry about it. Okay. A rectangle parallelogram is length times width or base times height. So LW or BH. Some people call so if you have a rectangle, some people call this the base. Some people call this the height. So it's the same thing. And then you have a parallelogram. And then this is your height right here, perpendicular, height, base. So some people call this, but most people also call this the length. This is a slash, not a division. And this is width. That's what most people would call it. Either way, as long as you know to multiply these two dimensions and you know that these parallel lines, these are parallel right here, are the same. So the length, these two lengths are parallel and they're the same. It's an L and this is a height slash width. Then you're good. That's a rectangle. And that's just a simple property of a rectangle. Same thing for parallelogram. It has the word parallel in it. So these two lines are parallel and these two lines are parallel to each other. Let's see. Give me 1 second. Okay. Triangle. Everybody knows triangle is half the area of a rectangle. Okay, we're good. Half the area of a rectangle. And you can see that because if you have parallelogram, you cut this in half. This is one triangle right here. Another triangle right here. So base times height times divide by 2, or 1/2 base times height. Trapezoid, your trapezoid right here, base 1 plus base 2 times the height, perpendicular height, divided by 2, all divided by 2. So put this in brackets. Or just do 1/2, B1 plus B2 times H is area. And a circle is pi r squared. Okay, so I did a little recap on why it's pi r squared. I think I remember. So if you have your circle, right? And you have your center, pretend it's a closed circle, and you have your center here. And basically what you do is you make a bunch of like these pie slices, right? Make like a bunch of these pie slices and they all have radius r. Every single one has radius r in them, I believe. Let's see if I remember this correctly. And then if you make an infinite amount, like super duper small, if you make them really, 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 really small, like really small, they're all gonna have a length of radius r, right? Because it's the length of a radius. And if you just make them super duper duper small and you make infinite amount, right? You make an almost infinite amount, you basically make an infinite amount practically, and you roll it all out, you eventually get a rectangle where the dimensions pi and r squared. That's just how it works. That's just how the cookie crumbles. That's one of the reasons. It's kind of hard to visualize. You have to watch there's a video on it on YouTube, pretty well visualized. Plus, you guys don't know about like sector, arc length, and area of a sector, which is pretty important too. So, yeah. But just know that area of a circle is pi r squared. That's all you need to know. All right. I hope I stalled long enough. Okay, so here's a little warm-up review. So first part, find the area of each shape described. Keep any of your answers with pi. So I don't do 3.14, just keep it in terms of pi. And second part, find the missing dimension based on information you are given. So this is just simple algebra right here. So I'll give you guys a couple minutes to do it. Oh yeah, number 2, remember, diameter is twice the radius. And in order to find the area of a circle, you need the radius. So find the radius first from the diameter. Or you could just do this. There you go. You can do that. Make sure you keep it in pi. So baseline is to the height. Okay, that's good. Okay. Okay. Yeah, this one's just simple algebra. This one is just knowing your perfect squares. Dang, you've got some great answers, Jenny. Great answers. Oh, you guys, yeah, quick note, pi is spelled P-I. There's no E. It's not P-I-E. Perfecto. No? Oh my god, Hulk smash 1337. Plat 1. It's crazy. I spelled it wrong? Oh, did I spell it wrong? No. How did I spell it wrong? How should I spell it? How should I spell pi? Like all renditions of pi, no matter what pi. How should I spell it? It's spelled pi I-E. Or pi just go. Yes, I got it, Jenny. I got it. Don't worry about it. I will strive to learn the alien language. Also, that's got it in alien. Ah, I see. I see. I'm seeing some good answers. Some very good answers. Yeah, simple stuff. This is just simple area problems. May you know why 3 equals pi, which equals e again? Okay, so it's a meme. Don't take this seriously. But engineers will take it. So engineers in college or just engineers in general in their career, when they do math, they don't like using approximations. And pi and e are approximations at the end of the day because pi has infinite digits and e has infinite digits. So what they do is they force round it to something that's easy to work with and something that's whole. They don't like round approximations. Okay, if you're doing physics or science or stuff like that, then you would do approximations. So like e and pi, you keep that. But engineers, it's a meme. They made a meme out of this, and physicists make fun of engineers about this. They want something brutally rounded. They don't want any approximation. So they will round pi to 3, and they will round e to 3 as well. So pi equals e, which equals 3.
Approximation. That's even more of approximation.
No. So they don't want approximations. Like they want to round it. They want to like force it to be whole. Yes, I know that's a more of an approximation, but still, like they do not like decimals. And it's just a meme. It's just a funny meme. Pi equals 3, which equals e. It's because mathematicians, yeah, mathematicians make fun of this too because they don't do that. They keep it pi, keep e. They don't force it to become 3. But engineers are like, no. We gotta make it 3. We gotta make it 3. But it's just a joke. I don't think they really do it because you don't even use those numbers when you're engineering. You might, but very unlikely. Oh, maybe we do like circular arcs or something. But even then, it's not practical to use pi or e in any measurement if you're an engineer or an architect for that matter. I think architects do the rounding just to make everything easier. And plus, it's so much easier to build, right? You know, think about it. If you build 3.141519, or whatever the digits of pi are, 1.14159, 2 something, okay, then building that is just it's a pain in the butt. So that's it's just a little meme story. Don't take it too seriously. If you want to be an engineer, then go for it. If you want to be a mathematician, if you want to do whatever career job you want, it's just a way we make fun of each other. It's just funny. But I mean, oh my god, thinking about that, it's just too funny. You guys are just so confused about it. All right, I think you guys are done. So here you go. Here's the answers. Number 1, very simple, 6 times 9, 54 inches squared. Number 2, obviously, you just find half the diameter. So you get 6.5 millimeters, and then you just do 6.5 squared, which would give you this answer. So 42.25 pi millimeters squared. One whole square area is a 64, but the half of that is 32. This one is just 2 plus 3 times 10, but you got to do 2 plus 3 first, and then you divide by 2. So 50 divided by 2 is 25. Simple enough, meters squared. Make sure you remember the units. Always remember your units. That is 4 times 4. 16. 4. Perfect square. Pretty easy stuff. And last one, I believe it's 13, right? Just lots of simple algebra. Oh, I didn't multiply this by 2. You get the idea. I'll just set it up real quick. So what was it? 132 equals 8 times 20 plus x, all divided by 2. So you just multiply this by 2, and then you divide by 8. So let's see. 132 times 2 divided by 8 is 33 equals 20 plus x, and then x is 13. There you go. Pretty easy stuff. You like pies? And you guys are disgusting. I'm joking. I don't like pies personally. I hate pies. They're just too sweet in my opinion. Like I only no, I just don't like pies. No, I'm sorry. I just dislike pies. Straight up. You too? That's good. I'm a traitor. I'm sorry. I'm sorry. I did what I could. But yes, I just don't like pies. Okay. Volume. So everybody knows volume. It's the number of cubic units you need to occupy a given space without gaps or overlaps. So basically, if I had a 3D shape, how many cubes I can fit into it would be my volume. Obviously, your units have to be cubed when it comes to volume. So inches cubed, meters cubed, kilometers cubed, etc. Because there's 3 dimensions. So 3-dimensional means it has 3 different measurements. So usually we call it base, length times width times height. Usually that's what we call it. Yes. And maybe people don't know it. I don't know. Do you guys know why some people pronounce it height like a TH? Do you guys know? Because my teachers used to do that when I was a kid. They pronounced it height, base times height, length times width times height. Like they say height, TH at the end, not height. I just got so confused. I mean, it didn't matter. I knew what they were saying, but I was so confused at why my teachers would say height. Like length times width times height, not height. Yeah, I don't know. Have you guys had teachers do that? They say like, oh yeah, the height of the thing. I'm like, what height? Yeah, height. No, my teacher did that. Or when I was in 3rd, 4th, and 5th, they all said height. My 6th grade teacher didn't say. She said height with a T. My 3rd, 4th, and 5th grade teacher, they said height. And that kind of annoyed me a little bit. I'm not gonna lie, but yeah, just curious. Okay, and then this lesson, so definitely no rectangular prisms, cubes, pyramids, cones, and cylinders. I don't know if you guys have cones and cylinders. That's not commonly taught the elementary. And it's just a little preview. Okay. All right, so your cube. Cube is 6 squares. There's 6 squares in a cube, 6 different faces. V equals side cubed. So they all have equal side lengths. You just cube it. You just multiply it by itself 3 times for a cube. For a rectangular prism, you have length times width times height. This one part is height. This little vertical part. Not height, height. I can't get that. Yeah, I don't know cones. That's the only one. Okay. Yeah, I don't get that. They say height. It boggles my mind. It's crazy. But yes, length times width times height, or base times base times height times length. Whatever floats your boat. I was learned this way, and I'm gonna teach you this way. Length times width times height. Triangular prism. So this is basically base times height times length. Now this is because the triangle has base and height, and then divide by 2. So L is the length of this rectangular part. Then you have the base right here. Pyramid is, it depends on what your base is. Square pyramids, so A you just basically plug in whatever your area is for your base. So for A, if it was like a square, then it would be s squared h divided by 3. If it was just a rectangular pyramid, it'd be length times width times height. There's gonna be like a height right here in the center of it, perpendicular, and just over 3. So it depends on what your base is. What is going on? Okay. Give me a second, guys. Hold on. Okay. Sorry about that. So like I said, square pyramid, base squared, side squared, whatever you want to call it, divide by 3. Rectangular pyramid, length times width times height, divided by 3. And here we go. That's really it, I think. Triangular pyramids are a little tricky because you have to use a slant. So if I drew like a triangular pyramid, you have to use like a slant height. It makes it a little tricky because if you use the height of this, you have to use trigonometry to find out the hypotenuse of this. So they prefer you get a slant height because if you get the height in the center, which is what you normally get with a square and rectangular pyramid, then you just have to complicate more things and find the hypotenuse of one of the right triangles it creates. And you have to draw extra lines and stuff. And that's just geometry at that point. Okay, so cylinder volume is equal to pi r squared times h. It's literally the area of a circle times the height of a cylinder. That's it. That's all you need to know. And a cone is the same thing, except it's 1/3 the volume of a cylinder. So pi r squared times h divided by 3. And they always have circular bases because if they didn't, then they wouldn't be those shapes. So a cylinder looks like that. So your height is perpendicular right here, your radius, and then whatever the area of your circular base on the bottom times the height is your volume of a cylinder. And for a cone, same thing, same exact thing, just divide by 3. So 1/3 pi r squared times h. All right, this is a little example. A cone that is 2 inches tall is welded on top of a cylinder with a radius of 0.5 inches and a height of 10 inches. The cylinder cone figure is then welded to a cube with side lengths of 3.4 centimeters. Find the total volume of the entire figure in inches. Keep your answers in terms of pi and use 2.54 centimeters is equal to 1 inch for a conversion. And then round your final answer to the nearest hundredth. So yeah, so round your cube side volume to the nearest hundredth. And then when you add them all up at the end, just keep them in pi. I mean, you could multiply by 3.14 if you want. So here's what I'm talking about. That's what it looks like. So you have a cube right here with side lengths of 3.4 centimeters. That's a cube, by the way. You can't really see the line right here. Then you have your cylinder. This is different color. Let's go green. You have a cylinder right here that has a radius of 0.5 inches and has a height of 10 inches, right? And then you have the cone, which also shares the radius of 0.5 inches because it's on top of the cylinder and has a height of 2 inches. So yeah. So find the total volume, which requires obviously you add it up. It's total. So I'll give you guys a few minutes to do that. And you'll probably get a different answer from me, but that's okay. Don't worry about that. Okay, this is a moot point, but I really can't get over the fact that my teachers called it height. I still can't get over that. I'm just thinking about that now upsets me. I don't know. It just upsets me for some reason. And then you guys never had teachers that did that, which is odd because all my teachers did that. It's just sad. Maybe it's like an old school thing. Maybe they were taught like that back in the 20th century, and then 21st century is like it's just height now. I don't know. Well, nonetheless, GG. Nonetheless, here we are now, full circle. Yeah, you got the right idea, Jingwen, but don't multiply the last term by pi. Because what you wrote means that you multiply the last term by pi, which is not true. Yep. But yeah, you basically got it right. Practically. Oh yeah, so I'll put the equations. So this is for a square. This is for a cylinder. And this is for a cone. There you go. That's an H. Yeah, what's up? I got a raised hand. What's up, Max? You dread surface area? Yeah, I struggled as a kid. I struggled at it as a kid. I just could not wrap my head around like visualizing the net of the shapes or the net of the 3D shapes, or just like saying like, oh hey, I have to focus on the bottom and the top, and I had to go like the back and the front. Yeah, I kind of struggled as a kid, but then I just got used to it. I just did it. Practice. Pants talking to himself. Keck W. I am subbed but have nothing to say. Sadga. Isn't true. What? Don't worry about it. Oh no, he's gonna miss the cue. Oh no. I hope this wasn't too hard because the next one is harder. The question. This isn't hard. This is just long. This is long and complicated. Are you guys 3 more minutes?
$34.
3 more minutes.
34 minutes to do this problem?
You want 34 minutes or what? I said 3 more minutes, but I don't know what you heard.
No.
The next problem's even harder, so I might have to walk you guys through it. Although you guys probably will figure it out. You guys are pretty good at it. It's a little bit of algebra. No, it's not algebra really. It's just, yeah, okay, it's not algebra at all. You just have to write an expression for the next one. But yeah, as long as you know what to do. So you know that you have to find the volume of this cube first, or you have to convert this 3.4 centimeters to inches. Then you gotta find the volume of the cube. Then you gotta find the volume of the cylinder, and you can find the volume of the cone. Keep it all in pi for those two, the cylinder and the cone, and then you just add them all together. So if you guys, as long as you guys understand the total thing, I don't know if that's the right answer, Sarah, but it probably is. But hey, as long as you understand the process, that you find the area, find the volume of all three shapes, and then you just add them all together. And don't feel bad if you're like slow at calculating, because when you get older, everybody uses calculators. Yay! Everybody uses calculators because, like I said, when you get higher up in math, it's less numbers and more letters and symbols. For regular pyramid, you use the slanted side for the height. So for a triangular pyramid, when you look up the volume of a triangular pyramid, it says something about a slant height, which is basically the hypotenuse of a right triangle. If you draw out certain, like a bunch of lines and you create a right triangle, that's basically your slant height, because you can't use the regular height of a pyramid, which is the so yeah, you technically use the slanted side for the height, but you can't use the regular height that a pyramid would normally have. So if I drew like a square pyramid, and then I use this height from the center, that stems from the center, you can't use that for a triangular pyramid. It wouldn't be right. Yep. What am I talking about? Talking about triangular pyramids. They're a little special. How do we use trig to find the slant? Okay, well. Okay. I don't think you need law of sines, do you? Let's see. Let me think. Okay, well. Maybe not. Let's see. Give me 1 second. Let me think. I think you have to use special right triangles. I'm not so sure. When I think about it, because I didn't learn this either. I'm gonna look it up real quick. 90% sure you use special right triangle properties. You don't really get how to do this from? Okay, so that's fine. All you just gotta do is find the volume of the cube, then find the volume of the cylinder, and find the volume of the cube, or the cone, sorry. And you just add them all up. Add these three up. And then that's it. That's how you get it. As long as you understand that, you're good. So as long as you know that you do 3.4 divided by 2.54 cubed, and then you do 0.5 times 10, or 0.5 times pi, 0.5 squared times pi times 10, plus 0.5 squared times pi times 2. And as long as you know how to do that, that's good. You don't have to get the exact answer. Okay, maybe disregard what I said about slant height. I think that's maybe a different shape. That might be an oblique pyramid. Because I'm reading that a triangular pyramid can also use the height. Maybe
What kind of pyramid uses the slant height again?
That's a good question, because I actually have no idea. I think disregard what I said about the slant height. So don't listen to what I said about that. Maybe it's like an oblique pyramid. 9% sure.
What does a oblique pyramid look like?
An oblique pyramid. So most pyramids that you see are like right pyramids, right? Like they form right angles. So there's right angle here, right angle here, right angle here, right angle here. An oblique pyramid will have the tip, I guess you call it the tip of the pyramid, will be like to one side, will be slanted to one side. I think that's when you use slant height, because so then the height will be situated on like the one flat side. It have one flat side instead of like all 4 triangles. It have one flat triangle, and like everything else is slanted really far. You don't have to worry about that.
So how
Pyramids
do
are
we calculate the area? Like the volume.
base times length times height. So the area of your base times the height. I forgot which type of pyramid requires the slant height.
But for the regular pyramid, then is it from the base to the top of the pyramid for like the height?
Yeah, so for a regular pyramid, you just multiply the area of the base. So you find the area of your base and you just multiply it by the height. That's it. For a regular pyramid. Might be irregular pyramids. Well, we don't even do anything with pyramids, so you guys are safe. You know? And just you can look it up online if you're ever scared. Yeah, I totally forgot actually. Okay. Let's just skip through this. Oh, I forgot about this one part. Oops. Okay, so all you just gotta do is find the volume of each individual shape. So you get pi over 6 inches cubed for the cone, 25 pi inches cubed for the cylinder, if I'm not mistaken. Yeah. And the volume of the cube you convert, and you have all these messy decimals right here. We're to get AR for Zoom. What is an AR? Would somebody enlighten me what an AR is? You tell me, Jenny. Or yeah, I don't know. Oh, you want augmented reality for Zoom? That'd actually be pretty cool, actually. Oh my god, that'd be amazing. That'd be so troll though, because like the teacher is watching your face and then be like, "Oh my god, what's that behind you?" And then you just do augmented reality. All right, so this one you can either convert the side lengths first. Oh, does she? Let me see. No, I think that's AR is augmented reality. I think that's just like the background thing, because Zoom gives you, if you have a webcam, Zoom lets you choose your own virtual background. It's just a little special. I don't think it's AR. Zoom doesn't have AR. It's not that advanced. It's not that advanced, you know? Okay. But yeah, anyways, where was I? So for the cube, you can either convert the side lengths and then cube this side length that you get, or you can find the volume of the cube in centimeters and then convert it. Now notice that I divide by 16.387, not by 2.54, because it's centimeters cubed. So you gotta pay attention to your units. So it's 2.54 cubed. Because if you just did 1 centimeters, you would end up with centimeters squared. Times, if you did 39.304 centimeters cubed times 1 inch cubed over 1 centimeter, so 2.54 centimeters, 1 centimeter cancel out, because you're left with centimeters squared, and you would get your units as centimeters squared times inches cubed. Now, I don't know about you, but I've never built anything in units like that before. I've never built anything in units of centimeters squared times inches cubed. I don't think anybody's going to do that anytime soon. So yeah.
So what is the total, what is the actual answer for all of those combined?
This one. Approximately 81.46 inches cubed. If you did 3.14 for pi, or close to 3.14. Don't do 3 though. Don't. If you did 3 for pi, that's, I'm trolling you if I said 3 equals e equals pi. That's a, remember, that's a meme. So don't take that seriously. 3.14 is probably the best. Easy stuff, right? It's just long. All right, next one. Mo is trying to build a box with an open top. So he takes a rectangle with length 8 inches and length width 5 inches. Sorry. Then he cuts out square corners of length x inches. After he cuts out the corners of length x, he then folds the resulting shape into a box with an open top. Write an expression for the volume of the resulting shape Mo creates. So my man Mo trying to make an open box top, and this is what I'm talking about. So here, help you visualize it. So make sure you write an expression. So you have these corners, which all have length x, correct? You have all these corners, all length x. So these are squares. And he cuts these out. So pretend that when you see this rectangle, you're only left with this part, right? This part. I'm gonna highlight it. I guess I highlighted red. You're only left with this part after he cuts it out. Okay, maybe this problem is pretty simple actually. So then he folds up the resulting shape. So he folds these parts up and creates a box with the open top. So there's like no lid on it, basically. There's no top. So write an expression for the volume of the shape that is resulted. And you don't have to simplify it. You don't have to simplify the expression. Oh yeah, you don't need to know x if you're confused. X is the value of x is irrelevant. You don't need to know it. Just know that your answer will have x in it, obviously. No, that's not right. 8 times 5 times x now. I mean, Steel, how'd you, mein Gott, how'd you get the right answer so fast, you win? Oh, you forgot the formula? So formula for a volume in this case is length times width times height. Because this is a rectangular prism, but nice job that you win. She got that real fast. How'd you do it real fast? You tell me.
Well, you the rectangle is 8 times 5, which is 40.
Mm-hmm.
And then that square is length is x, and then x squared is the area of one of them.
Yep.
There's 4 of them.
Yep.
4
Yeah. That's good. Okay. That's good. Very nice. That's exactly how I would have done it. But yeah, it's pretty good. Nice. I wrote the answer differently, but that's just to show you guys like the volume formula. But yeah. How are we doing? This one's easy, pretty easy, right? It's just a matter of visualizing it. Just gotta visualize it. Once you open your third eye, everything becomes more clear. I forgot what that's from. I don't even know if you guys would understand that reference. Trying to get AR in Zoom. Like the virtual background or like actual AR? Because that's pretty insane. AR. Oh, good for you. I don't have, yeah, good for you though. Because I personally have no use for that. But it's funny. It's funny and it's troll. Oh my God. But yeah. What is artificial whatever? AI? Artificial intelligence? AI? AR. Just get Snapcam. Just get it. AR. Augmented reality. It's like a new technology type of thing. Yeah, but what does it do? It just so you say you had like a phone and you use your camera on it and you're recording a video, you just add stuff to the video. Yeah, you make something up here. You add stuff to the video that normally wouldn't be there, and it makes it look like it's a real reality. It makes it look real. Yeah, except it's not really there. So it's augmented. Augmented means changed. It's like a changed reality. So it's there on your screen, but it's not there in real life. And Amazon is trying to do that so people can like preview their products before they buy it. What they do is like, hey, we'll let you AR this item, right? So we'll let you see how it would look like if it was there, but it's not really there. And it's like, oh, okay, I want to buy it. If it looks good, if it doesn't look good, then I won't buy it. Okay, it's pretty short in time. So this problem is pretty easy. So you'll notice that the side lengths right here, this length is 8 minus 2x inches because this is 1x, this is 1x. So this resulting length would be 8 minus 2x. This one, same thing, 5 minus 2x, right? X and x. And the height would be x because if you folded this up, your height would be x. So in total, your equation is 5 minus 2x times 8 minus 2x times x. Length times width times height. And you can switch these two. And that's pretty easy, right? Pretty simple stuff. Or you could just do what Jingwen did, and I would do that too, is notice that you have 8 times 5 for the base times height, or length times width, sorry. And then you have 4 squares of x. And an area of a square is x squared. And you have 4 of them. So it'd be 40 minus 4x squared, which is what you would get if you simplified all this out. So there you go. Wait, I guess not. Oh, you're doing surface area. Oh, you're doing surface area. Okay. You were doing surface area. That's for surface area, but that was a good guess. This one is just simply multiply your length, your width, and your height. Because remember, so if you had this net out right here, if you did surface area, that'd be right. So if you folded this up, your shape would look like this, if I can draw this well. Right? And it doesn't matter if there's an open top or not for volume, because volume is just like sorting out with cubes, right? So this right here would be 5 minus 2x. This would be here 8 minus 2x. And the height is x. And you just multiply them out. And you would get 4x cubed minus 26x squared plus 40x. But 40 minus 4x squared, I believe that's the answer for the next part, surface area. Because I did the same exact problem with surface area. But yeah. That's pretty easy, right? I hope you guys got that. All right, surface area. So surface area obviously has nets. I hope you guys know what nets are. I know you guys know what nets are. So net is like a pattern of shapes that can be folded out to create a model of a 3D shape. So example, cube, like I said, 6 different squares. Most commonly looks like this. That's horrible. This is not to scale, by the way. Yeah, okay. Pretend this doesn't exist right here. Pretend this doesn't exist. 1, 2, 3, 4, 5, 6. So most commonly a net of a cube would look like that. And pretend these are squares. You guys know that. And triangular prism is 2 triangles and 3 rectangles, because it looks like that. And you can see 1 rectangle here, 1 rectangle on the bottom, 1 on the other side, and there's 2 triangles on both sides. And so each part of the net is a face of the 3D shape. So basically each one of these faces are shapes are faces of the 3D shape. And a face is like a flat or curved surface. Yes, you can have curved surfaces. And so surface area of a three-dimensional shape is the total area of all the individual shapes in the net. So the name says it all. It's the area of a surface on a 3D shape. It's pretty self-explanatory. So there are formulas, but most of the time you're expected to look at the shape and just visualize the net yourself. So there you go. Like I said, now I have a cube, 6 times s squared, because there's 6 squares. So s squared, s squared, s squared, s squared, s squared, s squared, 6 times. This one, I'm not going to write this out, but yes, this one's 2 times length times width. So that's one rectangle. 2 times length times height, it's another rectangle, or another 2. And 2 times the height times width. That's all 3. Triangular prism, that's a net of 2 triangles and 3 rectangles. And I guess it got cut off. Rectangles. That's a pyramid. Okay, I already showed you. So it'll look like this. Like that. It looks like that. And so it's base times height plus 2 times s times L. So side length is right here. And this is L right here. Plus the base times length. So same thing right here. So the base right here and the length. Right here.
I have a question. What is like the net for like a cylinder or like one of those cones?
So cylinder is kind of hard to draw, but well, not kind of hard to draw. It's 2 circles and a rectangle in between. Right here. Oops. So that's a cylinder, but that's not exact, because if you how do I explain this? Imagine if you have one of those cans, right, like Chef Boyardee or something, and you took off the wrapper and you unrolled it, you rolled it flat, you would get a rectangle, and you take off the both lids, the top and bottom, so you get 2 circles, and that'd be basically a cylinder. For a cone, it's a little bit more complicated, but I think it's a circle plus part of a circle, like a triangle. It looks like a sector part of a circle. It looks like that for a cone. But like this is way longer. I'm 90% sure. Let me think. Yeah. It's basically a cone is a sector of a circle, so it's way longer plus a circle. So that's why I didn't include that, because you don't know what sectors are. Yeah, sector is a part of a circle. So if I had this is a sector. One of that part. Okay, let's fix this. Square pyramid. Well, this is this one. Oh, this is this one. I put the wrong order. Base. So basically, it's your length of your base squared, because you want this squared, times plus 2 times base times slant. Base times the side length, slant height. Oh, so that's what it was, a square pyramid for surface area with slant height. But I'm not gonna make you guys do that. It's a little yikes if I did that. Okay, let's try an example. So find the surface area of this net. Should be really easy. Nothing too complicated. Or surface area of the shape, rather, I guess. Obviously, it's easier to look at a net when you you get surface area, but usually they only give you the shape, this part. Please teach you, maybe a different time, maybe a different time. Should be 12. 6, 6, 18, 12. I'll just add this all up. That would be volume, Wenjun. That would be a volume of this. So you're not wrong on the volume, but looking for surface area. 457 squared. 24 to 36. I think you're close, but is there something? Yeah, I got 72. Because it's 6 times 3, so you get one rectangle. 6 times 3, this part, this little rectangle over here, the front side. And then so it'd be 6 times 3 twice, because there's 2 of them. Then you want the rectangle on the right side, 6 times 2, so plus 12. And then since there's 2 of them, you multiply it by 2, and then plus the top and bottom. Bottom is 3 times 2, so 6 times 2, which would be 36 plus 24 plus 12, which should be 70, yeah, 72. 70 squared. Very easy. I didn't even give you the answer. That's how easy it was. Okay. So same question about, but this time do surface area. So you have your 5 inches, your 8 inches, and then he cuts the corners. Mo cuts the corners, x squared. And basically he folds it up. So folds these shapes up. And so you find the surface area and make sure you don't count the top part. So write an expression for the surface area, but make sure you don't count the top part. There's a bottom, but there's no top because he's making a shape with an open top. So make sure you don't count that. Okay, so actually, so you guys remember, so this length is technically 8 minus 2x inches. This is 5 minus 2x inches. So this is also 8 minus 2x and 5 minus 2x inches. So this is still x, x. All these are still x. The heights are still x. So the area of this one part, right, is 5 minus 2x times x. We gotta do it twice. So technically be 2 times 5 minus 2x times x. Then you have the 8 minus 2x times x on this one part. But then there's 2 of them, because there's one right here, one right here. So it'll be plus 2 times 8 minus 2x times x. Plus, there's only one of this base part. And this base part is 8 minus 2x from this top right here times 5 minus 2x from this one segment here. 5 minus 2x. And so 8 minus 2x times 5 minus 2x. And that basically is your answer. You don't have to simplify that because you guys probably don't know how to do that. And plus, it's actually pretty hard to do it. It takes a lot of writing. That should be 40 minus 4x squared, which is squared. So yeah, that's basically it. I think that's it for today. No, it's not. It's called quadratic. 40 minus 4x squared. Not quite. Well, let me think. Well, not quite. Not quite. But where do you get the 26x? Minus 26x. So here's the answer. So like I said, pretty easy stuff. You guys are free to go. This was easy, right? This one should have been really easy. You guys should have seen it.
Because 5 times negative 2x and negative 2x times 8. And then negative 10x.
Okay, let's see. So this would be 16, okay, 16x minus 4x squared plus this one would be 10x minus 10x minus 4x squared plus first scenario or last. I don't want to do FOIL here. I guess I'll do this. I'll just do the box method. I'm too lazy. Okay. Plus 40 minus 16x plus 4x squared. And then when you combine like terms, these cancel. These cancel. Oh, I forgot the 10x. Oh, whoops. I guess I forgot the 10x. Plus 40. Wait a minute. No, I did something wrong again.
It's not 16. It's not subtracting 16x. It's 26.
For this one?
Yeah. You
How
subtract
so?
10x and minus 16x equals negative 26.
Okay, first 40. Inner minus 16x. Outer plus 4x squared. Last minus 10x.
Yeah, so
Oh, I forgot the minus 10x right here. So then this cancels out. And so you're only left with negative 4x squared plus 40. That's your final answer, which is 4 times negative x squared plus 10. And the standard form of quadratic would be x squared minus, not the minus x squared minus k plus h. So technically it's not quadratic, but it's close. It's close.
it's not the proper form, but it's still quadratic.
Close. It's 6 for me right here because I live on the West Coast. Yeah, I haven't done this stuff in years. It's been so long since I've done all this kind of stuff. I've been baking my head too much with calculus. I actually forgot how you do most of this stuff. Because we just use graphing calculators and we just dumb everything down and be like, okay, just graph it and then show me the important parts of it. And that's basically calculus in a nutshell. Lol. Yeah. I mean, it's really not that. Calculus is not. It's not hard, I guess. It's really time consuming though. That's what it is. Science geometry, so I got a graphing calculator and you have no idea how to use it. Personally, I recommend you don't use a graphing calculator for those kind of classes, but I guess the earlier you learn how to use it, the better. But like, don't use it yet. Only use it. You're graphing. Yep, you guys are free to go. But yeah, personally, I would recommend that you don't use it. Just use it only like a scientific calculator. That's personally what I would recommend.
Okay, thanks. Bye.
Mm-hmm. Have a good one. Yep. All right. Any questions or I end it? Sorry about that. Today's lesson, you guys. Today's lesson is pretty dull because you guys, I figured you guys already know this. So I didn't want to bore you guys with like, oh, just do this random volume problem. It's close. But yeah, I have no questions. I'm going to end it. So I will see you guys next week. Stay safe, stay healthy, stay cool. I don't know. Summer is almost over. Summer is basically over. It's September. It's the middle of September. Stay active, I guess. I don't know. Exercise. Get lots of fresh air. I will see you guys next week. Bye bye.